So I built a little counter surveillance tool using a Jetson or a Nano, and it all came about from looking at Matt Brown's YouTube channel on IoT hacking. It got me into looking at some of the Linux skills and the hardware stuff like the chip extraction. And then next thing I was building a Marauder on an ESP32. And then I thought, you know what, let's try and build a Jetson or a Nano counter surveillance tool, portable with some software that you can walk around and see if you're being tracked. And I'm definitely not being tracked. I'm not in security. I thought it could be a useful device. I'd seen some other people do that on YouTube. So this little video is just about the steps I went through, and I'm going to post all the stuff onto my GitHub. That'll be in the link. And yeah, good luck with it. If you try and build one, let me know how it went, and I'll just walk you through what I did, the hardware I used, and the results, which I think were really cool. So we got a Jetson Orin Nano, the 8 gig on Jetpack 6, and it's got the reason I'm using this is because we're using an LLM which is native on the device to do some of the analysis. So what else we got? We're using for Wi-Fi sniffing the Realtek RTL 8811 CU. So that's a USB adapter. It's not my first choice actually. I wanted the Atheros AR9271 chip, which was great for monitor mode on Linux, but this Jetson, for some reason the driver wasn't loading properly, so we went for the RTL, the Realtek. It works really well and has got a good range to it too. GPS, this guy, really cheap stuff, £7 I think, £7 as well on Amazon. This is uBlock 7 USB dongle. It feeds the NMEA data to GPSD, which Sentinel reads via the Python library. So it's also got built-in Bluetooth, so I can pick up any Bluetooth device in its location, and it's scanning that all the time. So we plug that in. Actually, let me just this was made on my Bamboo Lab 3D printer, just because I wanted it to be small and portable. So we can just plug all that in like that. The Jetson's actually got a Waveshare UPS battery device. I made a little kind of grid just to let the fan give off a bit of heat, because it runs quite warm actually, especially when it's doing its processing using the Llama 3.23B model that's installed on it. And the battery lasts for a long time. Just size-wise, I mean, that's an Apple mouse. You can see it's not that big. So that just can fit in a backpack and or in a handbag, I guess, or a bag. Anyway, all works fine. Let's switch it on, power it up, take it outside, and see what happens. Okay, so quick run through of the software. Basically the GPS data's streamed into a window here, gives you a latitude, longitudinal fix, all that information stored in the database. It'll then ping a position, user position on the map, and the Wi-Fi sniffer and the Bluetooth are then collecting information on any devices in range. That's going to populate the estimated location of that device around the user. As the user moves, new devices will be picked up, and the database is storing tons of information on those, all done in Python 3, a bunch of dependencies, the Wi-Fi sniffer on monitor mode obviously, and yeah, it works pretty well. And we can then run in and look at the individual devices, identity, estimated distance, etc. This is then summarized as the threat level. So we've got one device. This is just demo in Flask at the moment, so it'll just bring up data, so the user can always see what's going on. Now this database gets very big very quickly, so pretty much every Wi-Fi device is broadcasting a whole bunch of combination of information. We take each one of these and we hash it into a 16 character fingerprint, and we even look at the randomized MACs which modern phones use, and we exclude the MAC from the hash. That means when the iPhone rotates its MAC address, this device will recognize it as the same physical device, and it's then tracking this information against a database for about 40,000 vendors for manufacturer identification. Everything is stored in SQLite, and I guess the most interesting thing is that at the end, because I use the Nano, we can take that database. It's quite difficult to find. We can see what which devices we think are following us, but the best thing to do is use an LLM with a very I would say sophisticated prompt to dive into that SQLite database and do an analysis. Now, on this occasion, there's no alarm running in the background because it's just the demo version. This is all written in Flask, by the way. It's using a single page leaflet map application. And yeah, all vanilla JavaScript, no build tools, no framework. It runs really nicely on a phone browser. And the idea is you have the unit in the backpack or in your bag that's picking up all the data, and then all that data is being served just through localhost onto your iPhone. I actually used a hotspot on the iPhone. So the LLM's running locally, obviously, on the Jetson, so no cloud, no API, nothing. So yeah, let's go and field test. Okay, so right now I am walking through London, and this device in my bag's passively capturing every Wi-Fi probe request, Bluetooth advertisement within range, and it's correlating each device against my GPS track in real time. The beauty about this is it's using spatial analysis, so because traditional Wi-Fi monitoring is just going to count how many times you see a device, but in a busy area like this you see hundreds of devices, phones, routers, IoT sensors. So what we're doing is clustering the GPS track I'm creating into distinct locations. Here, let's go to screen. The weather's terrible, so we'll just go to a screen share. And yeah, it's going to be picking up and categorizing each of these 133 devices into ones that are following me actively and ones that I'm leaving behind that are currently clear. If they come back into my location, they'll move up to watch and threat. And we can just look, if you're interested, in the devices that are in the threat, see how close they are, see what they might be. But like I said before, the database is big already, 133 devices, difficult to tell. So we use the threat analysis tool. It's an LLM. It's run entirely on device. No data left this box. And yeah, this is the intelligence report. It can do this every 5 minutes, every 10 minutes. It's going to do a deep analysis based on its prompt of all the data it's collected and report whether or not it thinks there's anything that potentially is tracking. So yeah, the LLM AI does the work really. And yeah, this conclusion is level green, as I would expect. And that's it. If you like, please subscribe.